Alright guys, here we are with our solving subtraction equations. So today for solving subtraction equations we have two learning targets again, which are the same as yesterday's addition equations. You will be able to demonstrate solving subtraction equations, and then also you will be able to write equivalent subtraction equations. Can you write them in different forms, different equations with different numbers, but representing the same amount? The whole idea of solving is this idea of equivalency, to have things represent the same amount but written in different ways. Okay, I'm going to move on to the next page if you need to pause to write that down. We're going to go straight to our examples. In our first example, what do you do to solve the subtraction equation here? So in this case, I'm looking at my problem. I have x minus 15 equals 7. Remember, our inverse operation of subtraction is addition. So addition and subtraction are inverses of each other. So in this case, we are subtracting in the problem. So in order to solve it, to get x by itself, when we solve an equation, we want to get x by itself. In order to do that, we need to add to both sides. That is the inverse of subtracting. What do we add? Well, we add the number we're subtracting from x. So in this case, we are going to add 15 to both sides. Add 15 to both sides. That's our answer. Okay? So, inverse of subtracting is adding. So we're going to add. What are we subtracting from x? We're subtracting 15. So we're going to add 15 to both sides. That's how we're going to solve it. Okay? If you need to pause, go ahead. Otherwise, I'm going to move on to my example B here. X minus 22.7 equals 31.8. So again, my variable is x. I'm subtracting 22.7. What's the inverse of that? Okay, adding. So I'm going to add 22.7 to both sides. And again, you have to do it to both sides. It's very important when you solve equations. You do the same thing to both sides. Whatever you do to the left side of the equation, you must do the same thing to the right side of the equation. Okay, and that's all you have to write for these examples. Okay, I'm going to move on. If you need to pause, go ahead. Example 2 is writing the equivalent equation. So in this example, when it says write the equivalent equation, not creating ones. Creating is when I want you to give me other ones that are similar, other equations. When I ask you to write the equivalent equation, this is when I want you to write x equals. What does x equal? Or any variable for that matter. Remember, you could use any variable. It doesn't have to be x. Okay, so I have x minus 64. Again, the inverse of subtracting is adding. So I'm going to do that. Add 64 to both sides. I'm going to put a plus 64 to both sides. Now this looks a little weird because you might be thinking, Mr. Gasson, we're doing 64 plus 64. That's 128. You're not really doing 64 plus 64 because this is a minus 64. So remember, we're getting x by itself. So what we've done here is we've taken away 64. It would be like if you had money in a bank account and someone took money away from you and they took $64. Now you're in debt, $64. But now they added back the $64 that they took from you. So now you're back to where you started. Okay, if I take something away and add that exact same amount back, I'm where I'm starting. That starting amount is our variable x. Okay, so it's not 64 plus 64 because we have this minus sign in front here. Okay, and so we've taken away 64 and added 64 back. So that still gets us to 0, okay? If I flip that around into the plus 64 on top, you see that? That gets to 0. So that's my x equals, and then on this side you add those up, and you get 107. Okay? So this is my work, and then my answer right here. Okay, so you need to be careful in this problem that you're not doing 64 plus 64. Don't forget, you got the minus sign out there in front. Those make those opposite signs, so that does get that back down to 0. You've taken away, and then you added it back. All right, I'm going to go to example 2b. Okay, in this one, again, here's my variable, and I'm subtracting 2 2/5. So the inverse of subtracting is to add. So I'm going to add 2 2/5 to both sides. Again, that's not 2 2/5 plus 2 2/5. You have the minus sign out in front of there. So that's taken it away, and you've added that back. So that's going to leave me with x equals. The denominators are already the same, so you add the numerators. 1 plus 2 is 3. Denominator stays the same. 8 plus 2 is 10. So you get x equals 10 and 3/5 is your final answer. And that is how you write the equivalent equation. Okay? If you need to pause, go ahead. Otherwise, I'm going to move on to example 3. In example 3, again, I want to focus on creating. So you want to write subtraction equations that represent the same amount. So the first thing you need to do is figure out what this amount equals. So I'm going to add 18 to both sides real quick, and that's going to give me x equals 41. So I want to write an equation where the answer is 41. Just like yesterday, I'm going to give you 2 examples. So the first one, I'm going to start with x minus, I want to use numbers less than 41 because I'm subtracting and I don't want to get into negative numbers, which we haven't talked about. X minus, I'm going to choose 20. Now remember, that's a 41 if that helps you. So I do 41 minus 20, which is 21. So if you want to check your work, you could always add 20 to both sides, and that's 41, and there is one example. Okay, another example of this, if I wanted to write one, is say I did x minus, let's say 9. Okay, again, that's 41. So that's 41 minus 9, that is 32. So x minus 9 is 32 is another example. So there's 2 examples of equivalent, creating equivalent subtraction equations. Okay, there are an infinite amount of possibilities you could use here. None of these are all whole numbers. You could get into decimals and fractions too. Make it a little harder, but you could get into that. All right, I'm going to move on to example B if you need to pause. Here's example B. So again, same thing, create an equation. So I'm going to add 11 to both sides. That's going to give me x equals 28. I'm going to write an equation. Again, I'll give you 2 examples. So the first one, I want to make them less than 28. X minus 22 equals, well, what is 28 minus 22? 6. So x minus 22 equals 6. Okay, 28 minus 22 equals 6, so that works. If you wanted another example, I could do x minus 9. Again, 28 minus 9. Oh, that's 19. So that's x minus 9 equals 19. That is another equivalent subtraction equation. So there's 2 examples that you could write for those. Okay? Make sure that if you had questions on anything, you go back and watch the video again. When you're done with the video, make sure that you do your lesson review questions and your summary on the Google form. Have a great night, and I will see you guys tomorrow.